Okay, the final part that we're going to learn about today is called bearings. And bearings are used to indicate the direction of an object from a given point. And what I want you to think about when you think about bearings are compasses. So you have the four main directions in a compass. You have north, south, east, and west. And the way you can remember is you go never eat shredded wheat. I don't know. You can just remember the way that those are organized. So due north is how we measure directions, right? So you always measure from north and then you go down to whatever you're looking at. So east would be 90 degrees, south would be 180, west would be 270, and then 360 would be all the way back to north. Okay, so that's the way that we would measure. Bearings. Okay, so let's do a problem to contextualize this, because otherwise it's kind of like, what? All right, let's go to question number 6. So, the following diagram shows 3 towns, A, B, and C. Town B is 5 kilometers from town A on a bearing of 70 degrees. So let's talk about how they would figure out on a bearing of 70 degrees. So let's say the picture was not given, right? It's from point A to point B. So from point A, you would always draw a line 90 degrees coming right out of A, pointing due north, okay? And then think of a bearing as A down to B. So you can write yourself a little arrow that says down to. So it's A down to B is 70 degrees, okay? You're always going to rotate clockwise. So the same idea, right? So we have B down to C. You can write your little arrow right down to B, 90 degrees out of B, down to C is your bearing of 115 degrees, okay? So step 1, draw your arrow coming out of north. And then step 2 is going to be draw your down to arrow, and that will tell you exactly where you're supposed to put the bearing on the picture. Okay, now it says find angle ABC. So ABC is going to be this guy right here, ABC. And we have to try to figure out what he's going to be. Okay, well first you should know that all norths are parallel. So this north is parallel to this north. So that means when I have a bearing, and there's a line here, that's a transversal. It's going to cut the 2 parallel lines such that this angle is congruent to this angle. Those are alternate interior angles. And then this angle is congruent to this angle. So 180 minus 70 is going to give you 110. And then this one is also 110. Okay. So this is very useful because now I have part of ABC, but I don't have this little piece right here. And the way that I can find that little piece right there is I can do 1 full rotation adds up to 360 degrees. So I can do 360 degrees minus 110 plus 70 plus 115. And I could just do that on my calculator real fast. Okay, so now I have 65 plus 70 is going to give me ABC. Okay. All right, my video glitched out there. I don't know why. Hello. So find the distance from town A to town C. If I look up at the picture, right, I'm like, okay, town A to town C is just me drawing a little line right here, and then I end up getting a big triangle. So I'm just going to rewrite the triangle down here because there's a lot going on in the picture up top. So I got A, B, C as my angles. So that means this is side C, this is side A, and this is side B. C is 5, A is 8. This is 135. And then the side across from it is unknown, and that's what I'm actually trying to find. I have the angle across or I have the side across from a known angle, and then I have the other two sides. That means I'm going to be using law of cosines. So I have AC is equal to the other two squared added together. So 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 135. I need to be in degrees because it's cosine of 135. I'm over here, I'm in degrees, and I'm going to type in 8 squared plus 5 squared minus, and then I'm going to put this all in parentheses because sometimes it gives me a weird answer if I don't. All right, cool. And then I'm going to take the square root of that. What? I'm going to take the square root of that. Get under the radical. Oh, look at this problem child right here. Okay. Let's try this again. There we go. And I get AC is equal to 12.1. Let's keep a note that we're going to be using the unrounded version for our further working, so I'm just going to write it down over here. Or actually, better yet, I'm going to put it on the picture. Yeah, and then I won't confuse anyone who's grading my paper. There we go. It's on the picture. Okay. Use the sine rule to find ACB. Okay, so ACB is going to look like this. ACB, so that's this angle right here. So the side across from that is 5. And then I have known angle, side across. That's going to be law of sines, baby. Okay. So now I'm going to have 12.0652 times the sine of ACB is equal to, and then let's find the other piece in here. Divide both sides by that. 12. And then keep in mind that I have the sine of this thing. I don't have the actual angle. So let's inverse sine both sides. No, we'll get out of there. And we would get angle ACB is equal to 17. Oh, that is a very strange 7. 17.0 degrees.